Well, thank you for coming to Everything Matters, Tales from the Periodic Table this evening. I'm Ron Hipschman. I'm going to be your host for tonight's talk. Tonight I'm going to talk a little bit about the chemistry and the history and some of the common applications that you'll find arsenic in, so I hope you enjoy that. If we move on to the periodic table, which is what it's all about, arsenic is element number 33 right there, and I can't believe we've actually made it up to 33 elements since we started at element 1. The 33 in arsenic is how many protons are in the nucleus. It's called its atomic number. And every month we move up one atomic number. So arsenic got its name actually starting in the Syrian word al-zarnika, which actually came from a Persian word, zarnik, meaning yellow or literally kind of gold colored, because some of the minerals that arsenic colors are very gold in color. This was adopted into Greek as arsenicon, and the Greek word was adopted in Latin as arsenicum as well, and then the French translated that to arsenic, which is where we get our word. So it's been quite an evolution. Normally it's not quite that long of an evolution for our word. The first person to actually, we believe, to isolate element from a compound was this fellow, Albertus Magnus, and he did that in about 1250. So it was a really early element to be isolated, and he did that by heating soap together with a chemical called arsenic trisulfide. Arsenic actually does occur natively in nature. You can actually find native arsenic and just chip it out of the rock. Here's a piece of native arsenic, but that's not how we normally find it. It's normally found in compounds. One of the compounds that is found that we refine it from is one called orpiment, which is arsenic sulfide. Beautiful. There you can see the gold color. And arsenic has some really nice colors to it. This is A2S3, but in a slightly different combination. It's an element called realgar, which is AS4S4, another sulfide mineral. Look at that beautiful ruby color. It also appears in an element called arsenopyrite combined with iron arsenic sulfide. For those of you who remember back when we did iron and sulfur, we looked at a couple of sulfides, and fool's gold, pyrite, is iron sulfide. And actually, there's beautiful elements all. This is a lead sulfide called galena. So come up and take a look at that after. I don't have any pyrite with me, but I did have some galena. Just happened to have some galena in my office. But that's one of the elements that they mine arsenic from. Usually what they get out of these minerals is arsenic trioxide, As2O3. And it's just a white powder, and this is, if you watch the entire arsenic and old lace, is what the sisters use to poison their victims. It's the kind of a precursor and what they use to get to the elemental arsenic, the arsenic alloys and the arsenic used in semiconductors. Actually, if you combine this with copper, it's used, as you'll see later on, as a wood preservative in the United States and Malaysia. Most of the arsenic comes from China. Again, probably not surprisingly, a lot of China is a huge producer of minerals. Other producers around the world, Russia, Mexico, Chile. Arsenic looks kind of like a shiny, if it's not oxidized, looks like a shiny metallic substance. It's cheap. It's not a real expensive element. I'm sorry I don't have any here to show you, but I figured the air is poisoning you enough without actually bringing any more poisons into the room today. So it's pretty cheap element, even though it's not particularly easy to get to. About $10 a kilogram. It's pretty cheap, and that's for crude 99% pure arsenic. So it occurs in nature. If we look at the universe in general, arsenic is the 41st most abundant element in the universe. That's by mass. So it's actually pretty pretty rare in the universe. If you look at, there's a lot of, I mean, obviously hydrogen is the most abundant element, and arsenic's kind of way down there. It's like 0.8 of a millionth of a percent. So it's really, really low. Surprisingly, in the sun, there's none. There is no arsenic in the sun, and I suspect that's because inside the sun, the arsenic is used up by various nucleogenic processes. In meteorites, it's the 34th most abundant material, and that's actually probably the highest of anything in meteorites. If you look at the crust of the Earth, it's way down at the 48th, and in the oceans, it's the 28th most abundant element in the oceans. And in humans, surprisingly, you have arsenic in you. Not much. It's only like 5 millionths of a percent, but it is in humans, and we'll get to that in a moment. So, in the universe, arsenic is produced, there it is produced only in giant stellar explosions, supernova. So why is there any in the Earth and our solar system? Is because we are the result of supernova that have then spread their elements throughout the wherever we are in the galaxy, and those elements have condensed again as with the hydrogen gas that formed our sun and our solar system. So it's part of us, and we are part of. You have supernova stuff in you. This Carl Sagan used to say we're made of star stuff. Well, actually, we're made of supernova stuff. It's even better. So arsenic has lots of isotopes. We talked about isotopes before. Isotopes are different forms of the same element. I mentioned there's 33 protons in the nucleus of arsenic, but there's different numbers of neutrons. So always 33 protons, because that's what makes it into arsenic, because that means that there's 33 electrons surrounding the nucleus, and all chemistry happens in the electrons. But you can have different numbers of neutrons. So here's a little table that shows you all of the isotopes of arsenic. There's 33 isotopes of arsenic. And the number you see up here, the 60, 61, 62, those are if you add up the total number of particles in the nucleus, protons plus neutrons, that's what that number is. Remember, there's always 33, so you can find out how many neutrons by just subtracting 33 from those numbers. But those are all isotopes, but they're not all stable. As a matter of fact, there's only one stable isotope of arsenic, and that is arsenic 75. That's the only stable isotope. So naturally, since all the rest are radioactive, that's the only stable one. Arsenic 75 makes up 100% of all the natural arsenic. And if we look at the half-lives of some of the radioactive versions, the radioactive isotopes, you can see here the reason that there's nothing else other than arsenic 75, because the longest lived isotope only has a half-life of 80 days, which means that after 800 days, it's virtually gone. So unless you're generating radioactive arsenic somewhere in the Earth, it's all decayed away in the 4.5 billion years the Earth has been here. So all these would have to be made artificially. Arsenic is a metalloid. It's not quite like a metal. It doesn't conduct as well as a metal. It doesn't, when you hammer it, it's brittle. But it's, if it's kept away from oxygen, it's a beautiful silvery color. Sort of like last month, we saw germanium was kind of the same way. It's kind of a metalloid. It's a brittle, silvery material. It has a density that's kind of middling, 5.7 grams per cubic centimeter. Remember the density of water? 1 gram per cubic centimeter. And there's some others down here. So you can see the densest stuff, osmium, is very dense, 22.5 grams per cubic centimeter, but like gasoline is less dense than water, which is why it floats on water. And so does sodium. Sodium metal floats on water. If you go back and watch the sodium video, you may be able to see that, or just look online for people throwing sodium in water. There's a lot of those videos. I have down here, just in case you want to feel densities, how much mass is in a certain volume. There's some density blocks down here ranging from wood, a maple block over there, all the way over to tungsten. Tungsten is incredibly dense, over 19 grams per cubic centimeter. So come on up after and check those out. All but the tungsten are about the same size block. The tungsten, I haven't figured out how to cut it yet because it's really tough stuff. But if you lift the tungsten, use both hands, because if you drop it on your foot, it will leave a mark. Here's the range of densities. This is the densest element up here is osmium, all the way down to the gases, which are the least dense. And the stuff I have here, there's tungsten, and we have lead, and copper, and iron, and titanium, and aluminum, and magnesium, and finally, you can see where arsenic, which you cannot feel the density of, because I do not have a block of arsenic here for you, but it's fairly low. It's not a super dense or super light element. As far as hardness goes, it's kind of a soft element. This is the Mohs scale of hardness, where diamond is 10 and talc is 1, and arsenic falls right there around 3. So it's a pretty soft element, easily scratched with steel, which has a hardness of about 5, but cannot be scratched by things below that. There's an interesting thing about arsenic. If we look here at the melting point of arsenic, the melting point of arsenic is actually moderately high at 817 degrees C, or about 1,500 degrees Fahrenheit. But what's actually really interesting here is that the melting point is at 800, but the boiling point is at 600. It boils at a lower temperature than it melts. What does this mean? Boiling is what? Is the process of turning things from a liquid into a gas. Melting is turning things from a solid into a liquid. But if the boiling point is lower than the melting point, as you heat it up, it turns directly from a solid into a gas. It sublimates. There's not many elements that do that. Like dry ice does that. When you heat dry ice up, it turns into, there's never a liquid, at least at room pressures, at atmospheric pressure. You can't have liquid carbon dioxide. It turns directly from a solid into a gas. And so arsenic is a really interesting element for that. It has a lower boiling point than a melting point. And there's the boiling point, a little bit lower. It has a fairly small atom. Arsenic does. It's bigger than hydrogen, of course, but it's fairly small compared to a lot of other elements. Its spectrum is nothing spectacular. It has a lot of lines in the blues and cyans, and it's kind of red deficient. So if you actually put arsenic in a flame, don't do this at home, it would actually kind of make a bluish flame. And I guess you could color fireworks bluish with arsenic. Probably wouldn't recommend it. One of the interesting aspects is it kind of conducts electricity, and it kind of doesn't. It's among these elements in this in the blue there that are semiconductors, and that means it's kind of useful for making electronic devices. Specifically, well, one that you're familiar with are LEDs. Especially, well, it's kind of hard for you to read here, so I'll just circle the ones that have arsenic in them. Infrared, red, and orange and yellow LEDs have arsenic in them. It's it's an impurity. It's a dopant in there, but it's one of the things that helps make them glow, those colors. There are no LEDs that have shorter wavelengths than yellow, so no green, blues, or violets. Here's a good spectrum of LEDs here, and these LEDs over here are the ones that have arsenic, and none of these have arsenic here, because it doesn't have the right electronic structure. But arsenic also is used in high-speed electronics, high-speed transistors. Your cell phone probably has arsenic compounds in the chip that does the transmitter. The microwave transmitter in your phone has high-speed circuits, and these actually high-speed circuits are really cool to look at because the the circuitry itself, the wires themselves, the positioning of the wires actually make a difference. And so they tend to be real sculptural. I think they're really beautiful because it's more like plumbing than it is wiring. So, what other uses? I mentioned already that arsenic combined with copper is used to treat wood to make it mold and fungus proof. Again, probably, I don't know if they still do this, because if this wood gets into the environment, then you have toxic wood in the environment. But in the past, it was used for that. And also in the past, it was used not only to keep wood from rotting, but it was also used to kill insects. So here you see some Acme. Yes, coyote used this stuff. Coyote, Paris green insecticide. And this is actually combined with copper acetate and that white powder, the arsenic trioxide, and that gives this beautiful green copper color to this stuff. It's also used in dyes. So here's Paris green, which really talks about the color, not the content. Paris green dye for paint. One place that the dye actually got used in paint in the 1800s, and this is kind of an interesting story, was in wallpaper. So in the 1800s, these green Paris green pigments were used in wallpaper, and which was really a problem. They became very popular. William Morris was one of the designers of these wallpapers, and the problem here is when the air is damp in the winter, mold can grow on the wallpaper. And when mold grows on the wallpaper, it actually converts some of the arsenic in the wallpaper into arsine gas. So people who are exposed to arsine gas tend to get, well, sick because it's a poison. And so people noticed that they tended to get weak and sickly during damp winter months. And if they moved to a drier climate, they got better quicker. So damp weather became bad for you. Vacationing on a sunny island became good for you. And it took like 100 years before people realized it was actually just the wallpaper. But by then, the myth that damp is bad for you and heat is good for you was firmly established. So it became part of the mythology. Here's another shot. This wallpaper really is quite lovely. It's kind of the same thing, like where it becomes part of the tradition, like homeopathy, sort of the same way. I mean, homeopathy it started around the same time, actually, in the 1800s, where they found that doing nothing, i.e. using a homeopathic remedy, was actually less harmful than some of the common medical treatments of the day. So when you switched from traditional medicine to homeopathy, you actually tended to get better, not worse. And so again, by the time people figured out that it was the traditional medicine that was being bad, not the homeopathy being good, that accounted for your improvement in health, it became a little too late, and the myth kind of homeopathy lives on to this day. So that green dye actually made it into clothing too, and generated some really interesting political cartoons. The only problem with it was kind of killing people, so I can't actually read this. It says the arsenic waltz. If I had my glasses, I could read that. Yes. Thank you, Joe. I really should wear my glasses up here. It became actually a way, arsenic was a way to kill people, and you could kill people quite easily with arsenic. Until this test, the Marsh test, was invented. It's kind of a sensitive way to detect arsenic, like forensically in a body. When arsenic was used as a poison, it was developed by a chemist, James, you'll never guess, James Marsh. And James Marsh, he published his test in 1836. And people were using arsenic, well, and especially in the form of this arsenic trioxide, was the favored poison. because it's odorless, it's incorporated into food and drink, and it was sort of, before the advent of that Marsh test, it was untraceable in the body. In France, it became known as inheritance powder. Yeah. The symptoms of arsenic poisoning aren't really very specific, and due to its use by the ruling class to murder one another, they actually arsenic became called the poison of kings and the king of poisons. There's actually one theory that Napoleon was actually, the reason he died was he was given arsenic and killed him. If we move even forward into this century, even after the Marsh test, excuse me, you can see here that arsenic was used to poison people. The ashes here of the dead woman were revealing traces of arsenic poison. Now, I have no idea why one would carry around a tin of arsenic, except that arsenic was used as a patent medicine. Here you see Dr. James P. Campbell's safe arsenic complexion wafers. It cured freckles, moth, blackheads, pimples, vulgar redness, rough, yellow or muddy skins, or other facial disfigurements, and they're permanently removed, and a deliciously clear complexion and rounding up of angular forms is ensured. Also, an absolute specific in dyspepsia, habitual constipation, malaria, neuralgia, rheumatism, loss of appetite, lackluster eyes, low spirits, want of vitality, malassimilation of food, headache, and hay fever. So, arsenic wafers, there you go. You didn't have to look far to find these things. Here in the Spokane Daily Chronicle, they actually advertised them. So beautiful women use Dr. Sim's arsenic complexion wafers. Recently, though, you may have heard about arsenic being discovered in bacteria. That bacteria taken out of Mono Lake, which is extremely salty and alkaline. Some scientists wrote up a paper that said they found that these bacteria, subject to those conditions of extremely high arsenic and extremely high alkalinity, actually took up, instead of phosphorus into their DNA structure, substituted arsenic. Unfortunately, that paper was withdrawn because it actually wasn't true. As far as the human body, we actually, the role in human metabolism, not really known. But poisoning does occur in multicellular life if quantities larger than needed get into you. So arsenic in groundwater is a problem, and there was some talk about rice being a problem, but I think that was also kind of disproven as well. So the quantities that we eat rice in, I don't think are going to poison you too much. There is, however, a drug that does have arsenic in it, and it is a drug called Trisinox that was approved for leukemia treatment in 2000. It's a chemotherapeutic unit that, I'm just going to read it here, for the treatment of acute promyelocytic leukemia. And it's only if your leukemia is unresponsive to the classical chemotherapy, and it's been shown to induce cancer cells to die. But due to the toxic nature of this drug, which is really just that arsenic trioxide that we saw before, it does carry some significant risks. That kind of leaves us kind of at the end here. We have our monthly haiku from Mary Soon Lee, hauled in for questions, blacklisted, cannot quite shake your poisonous past. So next month, Everything Matters, we're going to do the element selenium. That will be on December 20th at 8 p.m. And I also do another set of talks called Full Spectrum Science, and this month, in November, Full Spectrum Science only occurs on November the 25th, our next week, Thursday night. Obviously, none of us are going to be here because we're going to all be having Thanksgiving. But on Sunday, November 25th at 1 and 3, we're going to talk about making color. So I'd like to thank you all for coming. If you want to come up and play with the density blocks, please do. One of my favorite references, by the way, available in our store, is this wonderful book by Theodore Gray called Elements. It's a really wonderful book. I love this book. It has the best pictures in it. So I hope you all come up and play and enjoy your night here at the Exploratorium after dark.